Welcome everyone, and thank you for joining us today. My name is Geir Engdahl, Cognite's co-founder and chief technology officer, and I have the pleasure of welcoming you all to Cognite's 2024 product tour. At Cognite, we empower process and production engineers, maintenance and operations teams, and data science and business IT professionals to accelerate high-quality decision-making by providing simple access to complex industrial data. Before we begin, I would like to briefly detail what will be shared over the next 60 minutes. During today's product tour, we will live entirely in the product. We are excited to showcase the strides we've made in creating a highly collaborative and interactive experience for the industrial user. Additionally, you will see an increased focus on AI capabilities, including generative AI that is secure, trustworthy, and helps solve real industrial problems. Most importantly, you will hear directly from our customers and see how they are using Cognite Data Fusion to achieve operational excellence rapidly and at scale. For Cognite's product demonstrations, I will be joined by my colleagues in the product who will be guiding you through the interactive level user experiences we have created for operational end users and showcasing how we build the industrial data foundation required to power these experiences and provide the industrial context needed to deploy secure and trusted generative AI in industrial environments. This is a recorded event and will be made available on demand afterward. Questions and follow-ups are always welcome now and in the future on our customer community, Cognite Hub, which you can find at hub.cognite.com. Simple access to complex industrial data. This is our mantra that extends beyond liberating the data silos that exist within every industrial environment and incorporates how we provide context to that data for cross-data source insights in an interactive and intuitive user experience in our industrial data ops platform, Cognite Data Fusion. With simple access to complex industrial data in Cognite Data Fusion, our customers have been able to build, deploy, and scale solutions 7 to 12x faster. They delivered operational impact by shortening their turnaround times by hundreds of hours, by increasing their workforce productivity by 20%, by reducing their energy consumption by 15%, and by identifying root causes of issues 50% faster, and many other operational improvements. But what does it mean to provide simple access to complex industrial data? And how does this translate into rapid and scalable business impact? We must acknowledge this difficulty from two aspects, the simple and the complex. Every day, those working in industrial operations experience the complexity of making data-driven decisions within the industrial data landscape. They must work across many systems or applications, use offline spreadsheets for analysis, and manually find and incorporate information that exists only on paper. Even more concerning is that the complexity of industrial data is only increasing as unstructured data becomes increasingly important. In fact, it's estimated that over 40% of the operational value of IoT is extracting and monetizing unstructured data. Addressing the complexity of industrial data means being able to quickly extract data from the hundreds of OT, IT, and engineering data sources, regardless of data type. Time series, events, asset hierarchies, drawings such as P&IDs, 3D models, documents, images, and videos. Then we must unify this data with the help of AI so that we can understand which time series, drawings, and models relate to which asset or process. Once unified, we have the foundation to structure this information into data models that solve asset performance management, production optimization, or energy management use cases. But for this to work, it must be done in a way that is open, maintainable, and scalable. You deserve a solution that is built for changing business needs, regardless of whether new sites and assets are built as a greenfield or acquired as a brownfield. We will highlight how Cognite Data Fusion, our industrial data ops platform, provides an industrial data foundation to deliver site-level excellence that can quickly scale across your enterprise. While our previous product tours have focused extensively on providing the robustness needed to handle the complex industrial data landscape, we have also made significant strides in delivering this data in a way that is simple to access across a wide variety of industrial users. We are talking about process and production engineers, operations and field teams, maintenance teams, data science and business IT. At Cognite, we know teams and people must drive transformational change. Each of these critical business roles needs data that lives outside of their current domains. An operations leader needs to see related work orders. A field worker needs to see OEM documentation for troubleshooting, and business IT needs to access real-time data to deploy new use cases for their stakeholders. All of this requires openness, with the appropriate access controls, of course, to empower these teams to make high-quality decisions. Furthering the ability to deliver simple access to industrial data is Cognite AI, a suite of generative AI capabilities that we announced earlier this year. Cognite AI combines the power of publicly available large language models, such as ChatGPT, with the industrial knowledge graph that is at the core of Cognite Data Fusion. The industrial knowledge graph represents how our previously siloed data is related, connecting and organizing information into relationships that can be understood by people and AI. With Cognite AI, large language models are given the industrial context needed to provide deterministic responses within your operational context. Cognite AI's unique architecture prevents data leakage by keeping all data proprietary and resident within the security of your corporate tenant. It provides trust and access controls that give your teams full control over what data is accessible through our APIs. And it minimizes hallucinations by requiring all responses to utilize your industrial knowledge graph and provide full transparency to the information used to answer a query. Generative AI is a technology, not a use case. And today you will see how Cognite AI infuses generative AI functionality to increase the productivity of existing jobs, such as those for the connected worker, while also creating entirely new ways of interacting with industrial data, such as application building for data science teams. As Gartner recently stated, LLMs will become the preferred interface to enterprise data. And we will see some of these use cases throughout today's tour. Now it's time to see how Cognite Data Fusion brings all of this together. I promised this product tour would live entirely in the product. And as we zoom out, you can see we are already within Cognite Data Fusion. To begin, and in the spirit of collaboration, I'm going to tag Andrea Pastinaru to start by addressing the universal pain point across all of these stakeholders: finding relevant information.
Thank you, Geir. Now, before we go any further, I'd like first to take a moment to step back and give you the full experience of what it feels to work in Cognite Data Fusion. So I'm going to show you the new homepage, which has been simplified to be more user-friendly for our industrial users. Search is the most common starting action. So we have to put an enhanced search front and center. Users now can explore all data types in the traditional hierarchy search. Additionally, we have built generative AI into our search capabilities, so I can search in natural language, such as show me all the work orders that take more than 5 hours to complete in a specific program. When we perform the search, we not only do we get the results, but we also see the query that was generated to perform the search, giving full transparency of generative AI responses, as well as giving the user the ability to modify the search and refine the results. If you compare this to the traditional search, where the search is very specific and you have to sort and filter through potential hundreds of metadata fields, this reduces the time to find the information you are looking for. This is Industrial Canvas in Cognite Data Fusion. We developed Industrial Canvas to revolutionize the way at every level of the organization users can now collaborate and interact with industrial data. In this free-form, no-code digital workspace, users can work with any data type, such as documents, engineering diagrams, sensor data, images, 3D models, and many more. So they can actually share workspaces, they can tag colleagues, and they can share the insights. But now let's showcase a bit more how you can actually benefit from the canvas. Now we have already added a PNID, but now we want to see what is upstream and downstream of this process, so we can add additional documents. I can quickly see what these documents represent, as I can get a summary of the content, and I can also ask questions to find insights faster. So everything actually is just being generated by using generative AI. As you can see, I'm getting actually learnings and insights from previous root cause analysis documents, which makes my process so much faster. Now that I have identified the heat exchanger in question, I can actually highlight the area that needs more attention on the PNID. To get an even more thorough understanding and visualize the physical location, we'll add the 3D model, which, as you can see, it's very fully interactive. These 3D models are one of many open components with our industrial canvas and can be used across Cognite Data Fusion or third-party applications development as well. As I already know that my colleague is conducting some operations near the heat exchanger, I can actually tag him and ask him to check if he can perhaps detect that something looks off in the field. Now going back to the engineering diagram, we can see that each highlighted area on the PNID is clickable and can be used to fetch additional data to the canvas. Here we are really just following links in the industrial knowledge graph. I can quickly visualize current live values for sensors of interest and even signal with traffic lights based on some basic rules. For example, if the value is above a certain point to be marked with red, as in this case, and below a certain point to be marked with green. Finally, we'll add some work orders, and we can see that we have recently done some maintenance on this piece of equipment. Still, we're not quite sure yet what is the issue, so now we want to perform an analysis to see if this piece of equipment is performing as well as it was before the maintenance. We have the time series data already contextualized on this PNID, so we just select the relevant data and start our analysis. As I need to perform some calculations, I'll just continue my investigation in our no-code charting and analysis tool. As we mentioned, Cognite Data Fusion is a product for everyone in our organization, and we do not need to be a data scientist or a data engineer to generate insights. Cognite is driven to deliver a product that is truly friendly for those who do not know how to code, but actually they need to solve day-to-day operational challenges and make faster decisions to improve their operations. We are now in our no-code charting and analysis tool, built for subject matter experts to explore, trend, and perform industrial time series analytics. It offers easy access to contextualized data, automatic time synchronization, and a powerful industrial data science library to gain actionable insights. This solution removes the painful process of taking data dumps from Historian, manually aligning these to the work orders, and performing analysis in Excel. So using this no-code analytics solution, we can actually build calculations, create alerts, collaborate, and share live insights with our colleagues. Continuing on with our use case, you can already see the data we have added from our industrial canvas, and if we need to add more data, we can just add it directly to our chart. Now that we have all the data that we need, we can actually build our calculation. So once the calculation is created, as you can see, we automatically get the current and historical trends. We can also check the data quality of all the time series tags, add related work orders, and see where they were completed. The calculation that I have created can be saved and made available for use inside and outside of Cognite Data Fusion. We can also set up monitoring on this data, so we are notified if unexpected events occur from now on. I can observe now from this chart that the performance has been affected after the maintenance work. So as I wrap up my analysis, I can go back to Canvas and visualize the analysis that I just created. Now I have everything that I need in one single collaborative view. I'm ready to share my work and insights with reliability and maintenance engineers and invite them to either contribute or use the results. As you can see, we're actually looking at all sorts of data from several different sources in a single view, and I can easily use a variety of data science functions or even my own models without writing a single line of code. As we mentioned at the beginning of the product tour, Gartner predicts that large language models will become the preferred interface for enterprise data. For this to become a reality, how we interface with and build industrial applications must radically differ from today's current processes. For example, generative AI can help replace manual workflows with workflows that are augmented by AI, enabling IT and domain experts to develop tailored solutions within Cognite Data Fusion by using Streamlit and Cognite's Copilot. Streamlit is an open source application framework allowing domain experts to build Python applications. Our Copilot is based on ChatGPT, and we trained it to understand our APIs and Python SDKs, as well as the Streamlit Python low-code UI framework. So now I can just create a mini application describing what I want in natural language. For example, I just simply tell the AI Copilot to create an application with a time series connected to the heat exchanger that we are just investigating. And the code is just being generated by Copilot within seconds. I can apply the code and the app runs interactively in the UI. Any changes are reflected instantly as well. This ability to generate apps within seconds, share, and scale them will significantly shorten the time to build new applications and scale solutions across the enterprise faster. It's important to note that the reason we can apply AI this fast is because of the robust industrial foundations, which we'll talk about towards the end of our presentation today. Now that we have shown how users can build no-code insights with an industrial data science library and tailor solutions with Streamlit, accelerated by a Copilot, I'm going to pass the virtual mic to Elias Bjorne, who will actually share with us how Cognite Data Fusion enables field engineers to be more efficient and productive and get the insights they need to make better decisions.
Okay, thank you, Andrea. So now let me show you how Cognite Data Fusion provides simple access to industrial data to field workers and engineers through our solution for field operations. So this is how Cognite Data Fusion looks on a mobile phone. It improves field productivity by helping workers locate equipment in 3D on any mobile device by providing instant access to all relevant data related to the equipment and task. A version is also available on desktop where engineers can see time series, trends, documents, and available equipment properties before they go out in the field. For example, here we see some work orders. Historically, they have been only available through CMMS systems, but our solutions put all of this data from CMMS systems in the context with other IT and OT sources. In addition to providing field workers with all this existing data, the solution provides a simple and paperless way to complete work in the field without extra unnecessary interruptions. Field engineers have easy access to a digital checklist that contain the data we've just looked at, along with a consolidated view of past, current, comments, statuses, readings, and pictures. Additionally, because field engineers have access to all relevant data, they can use these data when they're troubleshooting directly in the field. However, in this example of troubleshooting a transmitter, it requires going through a significant amount of documents, and it requires a lot of effort to find the correct information and decide on the best actions. Instead, we can utilize the newest developments in generative AI to help workers look and search through these documents. Previously, they would have to scroll through many documents or know precisely what keyword to search for. Now, they can turn to a Copilot that reads their documents, and the Copilot answers based on available documents, and also gives full transparency on which documents were used to generate the answer. This is important as this allows workers to double-check answers they get, which again increases the quality of the observation and leads to better notifications in the CMMS systems, and helps prioritize corrective maintenance actions before the issues become a larger problem. While it's important to make the data available across field operations, it's equally important to make this information available across other teams, especially with our maintenance and reliability colleagues. For example, we can build a report that help improve asset performance management. So here we have such a report where we are looking across operations to see how many tasks the team has per shift, what's in the backlog, etc. Here on the left, we see that we have 2 manual readings in the last month that are both out of range, telling us that there's something wrong and that we need to take action. This is possible since Cognite Data Fusion runs on open APIs, which makes generating these reports easy. From these data, it's also possible to measure what kind of work is being performed by the field workers and evaluate what part of the work can be improved or automated with robotics technology. So today, operators can spend as much as 50% of their time completing visual inspection, which can be done with the help of robotics. With the help of Cognite Data Fusion, you can deploy robots for remote and autonomous operations, where you and your colleagues can complete field inspections from the safety of your office. Operators can create missions pre-planned or on the fly that allows robots to capture data out in the field. In a typical scenario, you may come across an alarm or a specific equipment you want to check. And with Cognite Data Fusion, we can search and pinpoint the exact location of the equipment and then send the robot to this area. This streamlines the first responder scenario, and you no longer need extensive knowledge of your area to operate it remotely. Additionally, we have the capability to set up repetitive tasks. We can set up a regular schedule like every Tuesday, Wednesday, and Thursday at 8 a.m. and set the duration we desire. As the robot performs its work, the captured data is sent into our report. Here you can see and review all the collected data together with relevant and historical data, allowing you to analyze any changes to your most important equipment. Lastly, operators can view collected 360 images as a dynamic street view for improved reporting and tracking of changes. With simple access to all of this data, it can contribute to better planning, reporting, and be available for root cause analysis and across your organization. In addition, operators can leverage ML and AI models to automatically find failure modes and capture trends, which helps operators avoid manual review and promote preventive and remote operations. It's important to note that all the data collected by robots and captured during the mission is automatically contextualized and available across the teams and can be reported back as notifications to your CMMS systems as seen before. Now that we have shown how both people and robots efficiently capture previously offline information from the field, we want to show how this information no longer siloed in the paper log or a standalone robotics application. And our next speaker, Hunter Beck, will show and tell you how this information can be used to start planning our course of actions to complete the necessary maintenance that's needed.
Thanks, Elias. And, similar to supporting field teams and operators that work with robots, as Elias was showing us, Cognite Data Fusion is going to provide really seamless access to all of the relevant information that's going to help maintenance teams to perform successful planning and scheduling of maintenance and operations activities as well. And that includes critical ones, things like turnarounds or isolation boundaries where safety is critical. And rather than having 10 tabs open on a computer and dozens of phone calls and emails to create the most optimized plan, you'll see in the demonstration that we're going to go through in a moment that what we're providing is really full context across 2D, 3D, schedule-based views of all of their activities to support them at all the angles they need to consider in order to take really the most optimized planning decisions. And with that, I really just want to jump into the demo and show you what it's all about. So I'm actually going to start not with the maintenance planner perspective, but actually from the isolation planning point of view, which is something that would typically, of course, be done by your operations teams. And for them, logging into our backlog, taking a look at the activities that are coming up in the upcoming campaign, they want to filter down really quickly to just the things that I need to isolate. That's my task today. So just getting down to the relevant information as quickly as possible and taking a look at those work orders, verifying that they do, in fact, need to be isolated. And rather than just looking at the work orders or doing what they would do today, which is print off a bunch of PNIDs and start to do their isolation markups there, we can see is that because we've actually contextualized those PNIDs, I can take a view as the isolation planner of the PNID, where the work orders are in the process flow itself, and interrogate those work orders themselves, and actually start to do the isolation markups directly onto that PNID. So what we'll see here is we'll start to actually annotate the PNID with the various areas and boundaries that we need to mark up for isolation. And of course, I'm not going to walk through the entire isolation markup process here, but the point is that all of this information is captured in context. So now I have this full isolation markup package, if you will, that it contains where things need to be done, where the work orders are on the PNIDs, etc. And because I'm in operations, I'm also privy to information that maybe I want to let the maintenance planner know about. Things around the instrumentation not functioning or why I chose to isolate specific equipment. So we can see here that we can collaborate completely digitally here as well. I can add comments on those work orders that, again, is carried along with that bundle of information forward to other people in the organization that might need it. But now switching to the perspective of the maintenance planner, and of course, isolation is one thing that they care about, but they have to care about many other things as well. So taking a look at the activities that are in scope for the campaign, I can take, of course, those things, review the isolation status, but I can also review material status, the planner group that's relevant for the activity, and much, much more. I can also take that backlog and actually slice and dice it based on various other properties as well, essentially allowing the maintenance planner to interrogate the information so that they have all of the relevant perspectives considered during that planning process, that all the materials are going to be available, that nothing is going to block the activity at the point when it actually starts. And of course, that isolation plan that we started on earlier is now one more perspective the maintenance planner is able to take into account. So of course, they're not going to do the markups itself, but they're going to get the markups from that isolation planner, be able to review them here. But they're also able to take it one step further, which is rather than just assuming these work orders are the work orders that should be completed in the campaign, they're also able to compare against other work orders that are not in the campaign, but might be in the isolation boundaries. Well, that's an opportunity, right? If we're already going to isolate and shut down those pieces of equipment, then why not add those other work orders to the plan as well and take care of them at the same time? So an immediate optimization that we're able to do here to be able to tighten up the maintenance backlog. And it's not just in the process perspective as well. They're also able to look in 3D to gain spatial awareness for things. And that's, of course, relevant for a number of things in the planning process, whether that's checking scaffolding or just looking for proximity of work orders to see if you can maybe bundle things together in a way or sequence them in a way that your maintenance teams are able to take care of them more efficiently. And we're not just looking at work orders during this process. We can also evaluate risks. At the end of the day, you can see here we clicked on a risk from our risk management system, which is contextualized to the piece of equipment. We're able to see the details of that so that I'm also able to take that into account while I'm going about finalizing the process. But of course, all of this finalizes in a plan, in a concrete schedule and who needs to do what. And so what we can see at the last stage here is evaluating our plan and schedule with all those different changes that we've added to it as well. And that, of course, means taking a look in a Gantt chart, seeing how things have been adjusted, also evaluating, hey, I adjusted this work order forward or I added more work orders to my campaign. Do I have the resources to be able to actually execute on those optimizations? So again, not just adding the process, the 3D, the risk view of things, but also looking at the resourcing view so the planner can really take everything into account and see optimizations that have been made by others during the planning process so that they can make sure that at the end of the day, there's no conflicts and that as soon as work begins, they have everything ready and prepared. So with the canvas here, we can see that we have all of the information that we've been working with today. We've got the no-code calculations that we did with our process engineer to calculate and investigate the equipment. We have the Streamlit application that we built to be able to monitor that equipment and continue to use that information. We also have all the images and readings that were collected by our field engineer, but also by our autonomous robots that can quickly be found in context here as well. And finally, we have the work order information and a snapshot of our plan that our maintenance team did just a moment ago as part of the campaign that they're preparing for. Really, what this is showing is that subject matter experts no longer have to access multiple documents and siloed systems across a variety of siloed teams for the information they need, only to spend even more time analyzing data in another siloed spreadsheet. Your teams and people, they deserve an interactive experience that simplifies how they work, decreases the time searching for data, and ultimately increases the time spent collaborating and taking the highest possible quality decisions. And this is truly how we believe a collaborative, digitalized industrial organization should work together. And now, with that, we're going to move on to our final section of the product tour, and I'd like to turn to Elke Sierra, who will help us take a deeper look at the industrial data foundation that makes absolutely everything we've seen today possible.
Thank you, Hunter. Yes, all the use cases that my colleagues showcased today are powered by Cognite Data Fusion robust industrial data foundation, turning previously siloed data into open and dynamic industrial knowledge graph. The industrial data foundation ensures that accuracy, consistency, availability, and reliability, which is essential for enabling data-driven decisions, building and scaling solutions quickly, and streamlining and improving operational efficiency. So, how do we establish an industrial data foundation that is ready to serve both users and AI? The first step is to onboard IT, OT, and engineering data by using pre-built data extractors. We can find the extractors in our extensive extractors library that contain 70 plus and growing connectors for a variety of industrial systems, including OPC UA, SIP, OCSoft, OSDU, and others. I would like to introduce you our new MQTT extractor, hosted in Cognite Data Fusion. This innovative extractor enables a swift creation of MQTT connections. With our extractors, you can effortlessly establish connection, facilitating continuous monitoring that is both efficient and user-friendly. This not only streamlines your workflow, but also provides real-time insights, making it easier to interact with your data. Once we have data in Cognite Data Fusion, we need to understand how these previously siloed data sources are related by giving data context. Contextualization is the process of establishing meaningful relationships between data coming from different sources to digitally represent assets that exist in the physical world. Cognite Data Fusion delivers contextualized data as a service via AI-powered contextualization services using pre-trained machine learning-based models, custom machine-based models, and different rules. Cognite Data Fusion contextualization capability extend to the following types of contextualization. Machine entity, such as series or events to assets creating interactive diagrams, such as PIN-IDs and PDF, contextualizing images or 3D models, and more. Let's onboard the 3D model. Cognite Data Fusion supports all the most relevant 3D CAD formats that are used in the industry, as well as common point cloud formats. 3D models are versioned and processed so they can stream to any device with extremely high performance. We can contextualize this model to make it interactive. That means we need to link different 3D shapes to the relevant nodes in the industrial knowledge graph. This form of entity matching works on other metadata by looking at patterns and text. We simply select 3D model we want to map and the data set which we want to map it. Once we are happy with the matches we see, we can save them back to Cognite Data Fusion. Similarly to 3D data, engineering diagrams needs to be contextualized to become truly valuable and integrated into the knowledge graph. Our contextualization engine extracts information from engineering diagrams and documents to create fully interactive diagrams that contain connections to all corresponding equipment tags and related documents. Entity matching is then applied to map the detected symbols and text in the drawings to assets in the appropriate data model. When contextualization is done, we can preview and validate the results. We can also add more annotations in case the algorithm misses some assets. All the highlighted colored areas here match assets or reference to other documents. Through the contextualization process, we are creating dynamic data foundation. Now we will look at how Cognite Data Fusion modeling capabilities enable industrial users and use cases. With data modeling, we can create tailored experiences for the many different industrial users. When creating a data model, we can start by defining our own or choosing from the library of templates. Any sort of data, event, concepts, or parameters you want to capture about the process or your operation can be represented in Cognite Data Fusion. Plus, built-in versions control means you can draft and publish new versions while ensuring that all versions are still available to keep existing solutions running. After the data model is defined, it needs to be populated with data. To map raw data to define data model, you can simply drag and drop. properties from data sources to the specified places in the model. Cognite Data Fusion can automatically suggest how to map raw data to the defined data model, profile, preview, and inspect the AI-generated population to ensure you are feeding the data model with accurate, high-quality data. In addition, data models powered by generative AI, users can also explore them by using natural language to reveal data-driven insights. The data model defines the connections in the industrial knowledge graph, determining the type of nodes and edges that are allowed. Because of generative AI, knowledge graphs like this become more accessible to average users. Rather than writing complex GraphQL queries to interact with the graph, you can now use natural language. Generative AI, in combination with the data model, will then convert your query into GraphQL and execute it to retrieve the relevant data. You can also look at GraphSQL, what you would normally have to write yourself, to verify that the generated query is correct. Data modeling helps solve the complexity of industrial data and make it easier for developers, data architects, business analysts, and other stakeholders to view and understand relationship between data objects. It is not about one data model to rule them all, but having the capability to create tailored data models to solve a variety of relevant use cases. Now, it is time to show you how our existing customers are realizing business value from Cognite Data Fusion.
Hi, my name is Espen Norsven, working in Quantafuel as a senior automation engineer. Quantafuel is a company which upgrades plastic waste into new oil, making it circular. The process of turning plastic into oil is by pyrolyzing plastic into pyrolysis oil, which is then condensated through several stages to a final product. For us to have full control of the product and value chain and also the mass balance in the production, we are depending on accessing industrial data to perform our daily responsibilities. So today I'm joined by Andreas, which is our subject matter expert on mechanical. And he's going to show you how he uses Cognite charts to analyze highly variable complex processes in a no-code environment. Myself will show you how we can build tailored solutions with Cognite Data Fusion. So now just gonna show you a bit around how we're utilizing Cognite Data Fusion in our daily work. For the last 2 years, we have been working on optimizing the production and also optimizing manual tasks. In this example, we're using no-code software called Retool, which makes it very easy to make iPhone and Android apps connected to Cognite Data Fusion through an open API. This is an application for optimizing and digitalizing drain points in our plant in Denmark. So here the operator can choose the type of rounds they're using, selecting the correct time series related to the manual drain point, which is all a time series in the Cognite Data Fusion. Once they enter a volume and click submit, that will automatically update the corresponding time series. This makes it valuable for us because we can digitalize all the drain points and we have full control of the volume, which is drained manually out. That was previously a manual task punched into Excel spreadsheet. And over a certain amount of time, we kind of lost control. Now we're able to go back in history. We can make a bill of sustainability, which shows our complete environmental footprint. We're able to analyze the mass balance. We are able to have better control of the process in all. So Open API is easy to connect to. INRI tool, and we can both delete and update and create new time series, events, data sets, and everything through one interface in Retool. And thanks to Cognite Data Fusion, we save a lot of time and also keep a good and valuable insight into our process. So now we're just popping into Python, and just to show you how easy it is to extract information from Cognite Data Fusion and how easy it is to access industrial data. Previously, we only had SCADA system to rely on, and extracting data from that system into Excel spreadsheets was a time-consuming task. With Cognite Data Fusion, we are able to extract time series and data points and everything linked to that in just a number of lines and a number of minutes. And we can go back to the early beginning of our plant. In this certain example, we have optimized our production reports, which is basically reporting KPIs. That was previously done each day, and we spent a lot of time doing that. So thanks to Cognite Data Fusion, we are now able to extract all those data automatically into a predefined report. We actually saves a lot of time each day doing this.
Hello, my name is Andreas Selzer. I'm a package responsible engineer in Quantafuel, where I work since over 1 year now. I'm responsible for filter inside this plant, which is quite crucial for the performance or of the process lines. And the better this equipment is running, the longer it's running, the better is it for us. So my responsibility is to make this equipment running longer, better, without service breaks, to then prolong our production and keep the product lines in operation. So this is quite crucial for us because each stop, each break is costly, takes down the production, and no production, no money, and so quite important. So the other thing is too that we want to learn how we need to run the operation or the plant in a way not to harm this filter, prolong it, the lifetime of it, or the filter don't get too high delta P pressures over it. So I really look into all the facts which might influence it. It can be in the beginning of the plant, it can be in the utility system, it can be whatsoever, and just to get an overview which parameters are influencing the performance of this piece of equipment can be quite hard. Just to get from the small picture of this, or the small perspective of a filter, there might be parameters in the rest of the plant which are influencing it. If I need some data or want to analyze the performance of the filter, I just go to the web browser. I click on the Cognite Data Fusion, and it's jumping directly into the overview, the home page, and there I have my recent visited charts, and that is really nice. It's easy to find. I just click on it, and then it's opening up, and then I'm already there. On the left hand side, I can then add some more tags or time series, whatever I would need. But the nice part is I have done this already, and you can see here the hooks that what I have selected. So I don't need this anymore because I have done this and I have saved it, and that is so nice because I don't have to do it each time. So all these things which which you can see here, are tags which are in this chart, and I can choose make it visible or not. Today I have just chosen the delta P over the differential pressure over the filter to show, because that is quite something what we have tried now improved in the last run. It's quite crucial that this differential pressure is kept low and not rising too high, because if it gets too high, we have to stop our production plant. So what you also can see is that I have added here a threshold, and that is quite nice. You can add the limits, what you want the stuff to run in, and you can even show it, hide it, and have different thresholds with different parameters. So this can be switched on, switched off. I like to see it now because it's quite nice for this differential pressure. Here on top, I can then even stack the information. That is actually more helpful if you have even more parameters, but I don't want to or can add maybe a temperature measurement just to see that it's then the difference. Then it's stacked here. If I click it here, it will be moved down here, maybe not so good overview. So I like this a lot, because then you can separate the different data here. And then you can also choose the time frame in a way. If you just need to look at one day, it doesn't maybe see so much, but you can then look at some of the events and see, okay, why is it so high here? And now I could click in the other parameters and see what has maybe caused this high differential pressure here. Based on our findings, we have adjusted our process in a way that we can run better. So analyzing these charts and things like that was really helpful. Just for example, this here, this small development here, that small peak you can see in the beginning, that's the startup of the plant. And here to compare the delta P in the startup phase and this run, it's completely different. And that is what we have analyzed and found out. And the result is improvement for us. The good thing is also that these charts here are in a way my charts, but I can also make them public and can then share it with my colleagues all over the departments, or the people who have access here too. They will get the same stuff up, and we can discuss it in that way. Yeah, using the Cognite charts, it's really a big benefit because the data is easily accessible. It's easy to share with others. It's not time consuming. If after the setup is done, you have stored it, you can just use the browser. You are there. You can scroll in, you can scroll out, and you get your own perspective on the data you need. You save time. Just open the charts and you are there. So that is really good, and so it's for me easier to following up what's going on, and then that is helping me then to take the right conclusions to improve the process and support the decisions for the next testing, what we have to plan or what we have to look in, and to really get this plant up and running.
Hi, my name is Øystein Aspøy, and I'm the data platform manager at Aker BP, one of the largest independent energy companies in Europe. I am responsible for the Cognite Data Fusion platform in Aker BP. One opportunity we have seen is how to use generative AI to improve our data onboarding teams with easier access to data that is trapped in documents such as OEM specifications. The time we spend on manually loading data into different systems is quite substantial. We are operating assets with a large lifespan from when they were built. So we have a lot of old legacy solutions and systems, and we have a lot of new ones. And we're trying to stitch this all together and manage the information in the same way. When we first started looking into using generative AI and Cognite Data Fusion to pull information out of unstructured information, or to say it in an easier term, it's getting structured data out of documents, basically. We started looking into potential use cases or areas where we can use this technology. And we have found several places where this might come in handy. The first case we started out with was just looking at data sheets and how can we get this information that is today of laying in PDF files into a database where we can then reuse that information in all the applications we give to our users and the business to work with the equipment. So now let me show you how this actually works. If we look at one of our pieces of equipment, this is a valve. We have a lot of the information about this valve from the source in a structured way, but there are some pieces missing. So let's say that we would like to know the design pressure of all of these valves, and it would not be available here. We can use the document parser to retain that information for all equipment. And bear in mind that the equipment would be manufactured by different manufacturers and different solutions and over a vast amount of time. So we need something that understands contexts. And you could also do this for a lot of different solutions at the same time. So let's say that we had 100 valves with 100 different data sheets. We would ask the machine to find the design pressure of all of those valves, and it would, because it understands what it is going to look for. So now let me just find this information. You can see that in this data sheet, we actually have the design pressure. It's on line 7, and it says 87 bar G. So now let's run the tool, and now it's going to find design pressure on line 7, which is 87 bar G, and it's going to put that into our structured data for us. So if we now go into the data model we have populated with information, we can see that we have updated information about the actual equipment we were trying to extract. So you see on line 4, we have the manufacturer, we have a lot of information, and we also have the design pressure at 87 bar G. Yeah, if you look at the empty fields, if it can't find the information, it will actually say NA. And if it can find the field and understand that something is design pressure, but the field is empty, it will actually not put in anything. So you will actually handle both of those circumstances where you have the possibility of hallucinate or actually putting in something that did not exist. So moving forward, we would really like to test this at scale. We are working with a couple of use cases now where we are going to load a lot of information from documents into structured data, which will help onboarding of data for our users. And then we have a lot of plans for the future on how to go beyond that. How can we use this information to populate advanced backend system which is missing this data today, etc. So we would really like to enable the users themselves to use this tool both the end users, data engineers, equipment engineers. So it would help them to ease the pain today to get hold of the data.
Thank you for joining our product tour today. Today, we showed how simple access to complex industrial data can empower your teams and people to deliver scalable business impact. We also showed how the industrial knowledge graph built in Cognite Data Fusion provides the industrial context for secure and trustworthy generative AI. Before we close, we would also like to draw your attention to select resources you may be interested in. To learn more about how we can make generative AI work for the industry, we would be happy to send you a copy of our new book, The Definitive Guide to Generative AI for the Industry. In the book, you'll find practical advice on successful AI adoption and scaling, including use cases to inspire leaders to transform and accelerate their digital journeys via data and the power of generative AI. Also, if you want to take a deep dive into data contextualization, knowledge graph, and how context enables generative AI in complex industrial environments, watch our contextualization masterclass available at cognite.com. Last but not least, for follow-up, comments, questions, or discussions, please visit and join our open user community at Cognite Hub, available at hub.cognite.com. We hope you found today's product tour informative, and we would be delighted to hear from you. Thank you again for tuning in. We value your time during this tour, and we hope to engage with you soon.